Hello students, welcome back to project classes after a long time. Here I came with one question which is from aromatic alkoxylic substitution reaction. The question is what is the degree of unsaturation of the final product? Okay, so you know the degree of unsaturation is also called as the index of hydrogen deficiency. It is also called as a double bond equivalency. Okay, DBE, double bond equivalency or index of hydrogen deficiency or a degree of unsaturation. Okay, so here briefly degree of unsaturation is sum of the cyclic rings and sum of the pi bonds. Okay, so of course there is a different formula for the calculation of the degree of unsaturation, but if you know the structure of the compound, we can say easily by calculating the number of pi bonds and number of cyclic rings. Okay, for suppose what is the degree of unsaturation of the given reactant? So you can see in this for benzene ring, what is the degree of unsaturation? Um, here one cyclic ring and 3 pi bonds. So one benzene ring degree of unsaturation 4. So here totally 4 benzene rings. So here 4 into 4 that equals to 16. So degree of unsaturation of this compound is say 16. So then here the question is what is the degree of unsaturation of the final product? Okay. So here in this case, here acid uh, protonates this alcohol group. Here alcohol group actually acting as a base. That means here it is a Lewis the base, or we can say the Bronsted base. Okay, it is a proton acceptor or non-bonding electrons donor. So here this OH group get protonated first of all. Okay, so in this case here, after protonation of the OH group, it becomes a good leaving group actually. It becomes a good leaving group. Okay. For suppose here in this case at para position some groups are given. Okay. The groups are variable of course. So here we'll get the carbocation. So before the carbocation actually, so in this case, yeah, it is a benzene ring. Okay. Here OH and here H. The protonation of the hydroxyl group. Protonation of hydroxyl group, and one more phenyl group is there. Yeah. Now here it loses water molecule. Okay. That loses water molecule, and that produces a carbocation. You see in this case here carbocation formation. It is nothing but electrophile formation. Okay. It's like Frelikov reaction. You know that Frelikov alkylation reaction. So alcohols also can be used for the alkylation of the benzene. Okay. For suppose here you know that reaction, the benzene plus alcohol in the presence of acid medium. In the presence of acid medium. That means here we can take here HF or H2SO4 or phosphoric acid we can take. So actually here this acid is utilized for the generation of the electrophile. Okay. So here protonation of this OH and leaving of that group. So here that gives R plus and H2. So this electrophile attacks on the benzene ring. So that is aromatic alkoxyl substitution reaction. Here hydrogen, then H plus replaced by the this alkyl carbocation that is acting as alkophile. Of course, it is a field of alkylation reaction. Okay, so in alkylation reaction, generally we are using alkyl halide in the presence of Lewis acid, or of course we can use alcohol in the presence of protonated acid, or of course Lewis acid. And next. Alkenes also you can use. Okay, so alkenes by protonation produce carbocation or CH plus and CH3. Okay, so this is alcohol attached to the benzene ring. So here we can use alcohol, alkali halide, alkene to introduce alkyl group onto the benzene ring. Now here in this case, here alkyl group is given, the protonation and loss of water molecule, you get the carbocation. This is a alkylophile. It is an example of intramolecular alkylation reaction. Now here adjacent at ortho position there is a phenyl ring. So here in this case, this H plus replaced by this carbocation. Okay, that means there is internal attack of the alkylophile. So as a result of this internal alkylophile attacking, we can get the some 5-member ring, new 5-member ring. Okay, this is a phenyl ring, adjacent phenyl ring. Okay, this is the resultant compound. So here phenyl, these phenyl rings are as well you can write. Yeah, so that is the product. That means here from the reactant in the product there is a one more new 5-member ring is created. So its degree of unsaturation is 17. Okay, so that's the question which is from the one national examination. So thank you for watching.